There we go. Happy Garbage Day, everybody. Welcome back to school. The lovely semi-spring day. That groundhog did not know what he was talking about. So I made a change to your homework this morning. I want to see if anyone can spot it. You found it?
The due date.
Yeah. I'm going to give you 2 extra days just in case this topic stretches into Thursday. So it's due Wednesday night instead. I updated the printable version of the syllabus with this change, and I also changed the text here to say Wednesday! Exclamation point. But since I don't have a box for Wednesdays, I didn't move it. So a couple extra days to work on homework to make sure that we've covered everything with enough detail and to be able to have time to answer questions. So I have at least one question in the chat already about significantly weaker and significantly stronger. So have you all had a chance to at least open this, maybe? Or maybe you can nod and lie to me if you haven't, that's fine. So this homework, like all of the homework stories, comes from a personal experience. The idea of high-stakes mini-golf I attribute to my husband. When we were initially dating, one of the first trips that we made to visit his family, we decided to go play mini-golf with his sisters. We thought that'd be a nice activity. And I had no idea how much trash talking could be involved with a game of mini-golf. Like, his family was just, like, savage with each other. And I'm not very good at mini-golf. I play it maybe once a year. So that, like, on the mini-golf enthusiasm scale, which I named because it'd be like, Lisa, do you want to play mini-golf? Guess. See? Guess? I guess? No? Yeah, tough crowd. Anyway, I'm not very enthusiastic in this process, so I don't put a lot of stock in it, but some people do. And then when I played mini-golf before with my family, my father uses the fact that he's a regular golfer as an excuse for interference with his mini-golf game, because these are discrete sets of skills, at least with respect to some aspects of the putting. So that whole thing convalesced into this homework problem, in which you are examining the outcome of golf performance across 4 different training groups. So the idea is that there is a single grouping variable that has 4 levels, a control group, a group that has new training for mini golf, or new training for regular golf, or new training in both. And so some of the questions ask about the effectiveness of the new training versus control, and some of them ask about the idea of interference, like if you were trained in both at the same time versus people who are only trained one way. So I have a long set of instructions here to try and help you get everything set up correctly. The first section here is an empty model with no predictors. So literally just outcome equals the intercept, or the 1, and that's designed to get you started here. Section 2 is then adding the effective training group, and the way that that should be coded was described up here in the instructions. The control group should be the reference. And experience as a quantitative predictor. And then section 3, which is what the question was about here, is the extent to which the effective group depends on experience. So here's a pro tip. Whenever you see the words depends on, that means moderation. That means interaction terms. To what extent does the effectiveness of a group depend on experience? So I've already helped a couple people troubleshoot this particular problem, but the effective training group here, right, that's one idea, but how many slopes are you going to need to build to differentiate the 4 groups and how their differences are on the outcome? How many slopes are you going to need to differentiate 4 groups? 3. So the effective training group is 3 slopes right there. How that effective training group depends on prior experience, that's 3 more slopes, because each group difference needs to interact with experience. So if you get the first 2 questions right in here, you know that you have your model set up correctly. And then the question is figuring out what was provided directly versus what was provided indirectly that you're going to have to ask for. Okay, with me so far? Excellent. So then I have a question from Zoom, the idea of significantly weaker or significantly stronger. So it's particularly questions. So down here in the results, by the way, before each box, there's a Q and a number. That's the question number. That way, if you email me, you can say, I want to talk about question 60, and I'll know exactly where to go in the story. So here's a choice for significantly stronger or weaker. This one is referring to R square. So if I have a high R square, is that a good thing or a bad thing? It's a good thing, right? So anything that I add to my model, in theory, should make my R square increase. That makes it a stronger model in terms of strength of prediction. So the question would be whether it's significantly stronger or non-significantly stronger. If you're calculating it right, it shouldn't be weaker. So I'll give you that pro tip right there as well. Some of my distractors are not possible. Otherwise, let's see, 65, 67. So these questions are asking about the effective experience in the control group versus one of the alternative groups. And they are getting at the idea of the 4 kinds of potential interactions, which we talked about last week, but which I should probably review. So when we talk about interaction terms, this is slide 21, by the way, of lecture 1, we don't talk about what an interaction term does to y. We talk about what interaction terms do to the slopes that are embedded within, and then those slopes affect y. So if we approach it from that perspective, like if I have the effect of experience and it's being moderated by group, then that experience slope can become more positive or more negative in one group versus the other, or it can become less positive or less negative. If it's described as more of something, like if I have a positive slope, for instance, down here, if I have an x variable here and my slope is positive, and the effect of the interaction term beta 4, as z increases, then the slope becomes more positive by 2 for every unit of z. That's what these numbers would mean in this context. The way I would talk about it is that the slope of x becomes more positive as z increases. A more positive direction implies that the effect of x is stronger. It means more. It has more of an impact on the outcome. The second row would be the opposite pattern. Here, the main effect of x is still 10, it's still positive, but the negative interaction term is going to work against it. So here, as z goes up by 1, the x slope goes down by negative 2. It becomes less positive. So it would become 8, and then 6, and then 4, and then 2, and it would eventually flip over the other way. So the effect of these being in different directions is counteracting it. It's weakening it. It's moving the slope closer to 0. The exact same 2 patterns are available if you start with a negative. I think the key thing that you can look for is whether the direction is congruent or incongruent. If the 2 are in the same direction, they're working together to make the effect stronger as the moderator increases. If they are in opposite directions, they're working against each other as the moderator increases. So that is what I'm looking for in terms of application to this particular story problem. Inside the parentheses here, I have labeled these to try and help you keep them straight, because some of these are slopes and some of these are slope differences. Slope differences are interaction terms.
Okay, so the slope differences, that's what you were just talking about, where you're looking at both the interaction and the main effect, where just the slope for like 66 is just looking at that specific slope.
Mm-hmm.
And
yes.
so like the sign, the positive and negative versus the p-value, significant, non-significant.
Yes, so this first part of here is relative to the control group. In the alternative group, is the slope more positive, less positive, more negative, less negative? Another way of saying that is stronger or weaker. And then this is what is the slope in that alternative group, where significant or not is based on an alpha of 0.05, which is part of your instructions. I don't ever change that, by the way. So that is up here as that. And keep in mind that in golf, higher scores are worse, fewer strokes wins. So in terms of like which group had a better outcome, better means a lower golf score. And I know that could be potentially confusing if you don't do golf, but in the social sciences, there are all kinds of examples of outcomes in which more is worse. Like if you study, criminal deviant behavior or rates of poverty, or things like that, or amount of abuse. Like there's all kinds of things where more is worse. So just think of it that way. Also, I've got a couple of questions of this for those who are new to the homework system experience. Do you see how I've zeros everywhere in my thing here? That's because I haven't answered any questions. Once you answer these questions, whatever answer you put is going to be populated in the right spot down here, and it will be populated regardless of whether it is correct. Okay, it's just whatever you put is being brought down into the problem. I'm doing that so that you know what number you're trying to interpret here. Like, what is the sentence about? You can come back up here, find where you entered that number, and that will help you figure out where you should be looking in your output to make these decisions.
Can I ask a follow-up question?
Yeah, go ahead.
With the question 60 with the stronger versus weaker, so when it comes to significant versus non-significant, is that the p-value that goes with the interaction?
So the full sentence says there was
sorry, I'm talking about the other one.
The other one.
The other one we were looking at,
66? Were we looking at that one? I think that's
65.
right. 65. 65 and 6, yes.
6 would have to do with the p-value of that main effect. So then 65, is that the p-value of the interaction?
The p-value of the interaction, which I've labeled as a slope difference.
Yes.
Because it is the difference in the slope of experience between groups. So that's a more straightforward way of saying it than the interaction. So I have in parentheses here, slope difference or slope to help you figure out like which p-value we're talking about.
Okay, thank you.
Sure. And for the record, as we're working through these things, I can't tell you whether you're right or not if you come to office hours and be like, is this the right answer? But I can confirm your logic. Like if you talk aloud, like, you know, they've those think aloud protocols, like we do that where you explain why you're thinking the answer is correct. I can tell you if there's any problems with your logic. That I can do. And if you get stuck on something, please send me a screenshot of what you're stuck with, the code that you're trying to use, and I can help you troubleshoot to get to the right answer, as can our glorious TA, right, Vladimir?
Yeah.
Not many people have come to talk to you yet, right?
No.
Okay, he gets lonely. He gets lonely, has nothing else to do but wait for visitors for office hours.
Of course not.
Of course not. So, and he's getting up early in the morning to visit you, right? 9 o'clock is early. So,
Yeah.
all right. Other questions while we're on this topic? All right, so I'll give you extra couple days to get this finished. Let me know if I can help you. I have office hours too over my lunch hour. To be fair, I ate lunch at like 11 because I'm old, but your lunch hour. Anything else before I shut this down for now? I'll ask again on Thursday, so. All right, then that is that. Where we were then last time is adding to our interaction capabilities. So do you want to review these concepts a little bit, or do you feel like they're okay? Conditional versus marginal? What's the difference?
Conditional when this just slope interacts with another slope.
Yes, so a slope is conditional if it interacts with other predictors in the model. More specifically, it is at the interacting predictor being 0. That is what it means. The other interacting predictor works the same way. So if we have, for instance, a model that looks like this on slide 19 here, we have beta 1 is the slope of a predictor called W, beta 2 is the slope of a predictor called X, beta 3 is for Z, and beta 4 is the interaction term. So the slope of W here, beta 1, it's the change in Y for a 1 unit difference in W for everybody. I would call this marginal or unconditional because W does not interact with anything. So that means all I got to do is look at the results for W that are given to me directly, and that's all I need to know. Does W contribute uniquely after controlling for X and Z? Thumbs up or thumbs down? For beta 2 and beta 3, this is where I have to be careful. So beta 2 then is describing the slope of X, but it's only just let me back up again. Beta 2 is only the thing you need when Z is 0. Otherwise, you need beta 4 as part of the answer too. So if Z is 0, the last interaction term drops out, and beta 2 is all you have to look at for describing the effect of X. Otherwise, this is the effect of X in some kind of people specifically. Yes?
How would you know, like, in an output, if Z is 0 or not?
Well, the question would be, how did you set it up in your model? So if you have Z as a continuous predictor, for instance, you would have hopefully centered that predictor so that your 0 is somewhere within it, like it would represent the mean or the minimum or something like that. Otherwise, let's say that you had something like GRE scores, which are on a scale of 130 to 180 or something like that. Does that sound right? Something like that. I'm so old that it was on a 500 scale. Like I have a different metric entirely in my head. But if Z were GRE scores and you put that predictor into the model, then beta 2 would tell you the slope of X for somebody who got a 0 on the GRE, which is not even possible. So then not only is beta 2 like conditional, but it's stupid. Like it doesn't tell you anything useful. It's not wrong, but you can't really do anything with it until you figure out what a plausible value of Z would be and adjust accordingly.
If you put in Z as 0, if it was GRE scores in that example, right?
So that if you didn't center it, then it would be literally a GRE score of 0, which can't even happen. If you centered it, say, at 130, then 0 is the lowest score you can have. And so this would describe differences between people as a function of X when the people are who bombed the GRE, like that kind of person. If Z is a binary predictor, then this beta 2 slope of X would be for whoever the 0 group is in your binary predictor. Up to you who that is, but it's for somebody. So the rationale for centering your predictors becomes more important when you have these interaction terms, because the main effect slopes, that's what we call beta 2 and beta 3, main effects, they are conditional on 0 meaning something because of the interaction term. So where I see this go awry when people are like writing results sections is they'll talk about this beta 2 slope, being significant or not in the same absolute language that they would use for the beta 1, and that's just not correct. Because if this beta 2 slope happens to be not significant, it's like, for whom does this not work? There's no guarantee that it can't become significant at some point later on Z. And opposite is true for X and Z if you have Z as the predictor and X as the moderator. So what would we have to do, though, to figure out, say, what it would be for the 1 group? If I know that beta 2 is the slope of X specifically when Z is 0, what if I want to know if X matters in the 1 group, per se? Could I find that out? That's a reasonable thing. Is the model going to answer that for me directly? It is not in the way I phrased it, but it's still in there. So what would I have to do then to see if X has a significant effect in the 1 group for Z? Okay, let's go through it. Step 1, find all the terms in the equation that have the predictor whose slope you're interested in. Right now, my story is the X slope. Okay, step 2, only take those terms and carry them forward. So I don't need the intercept because X doesn't multiply it. I don't need the main effect of W. I do need beta 2. I don't need beta 3. Because we're talking about the slope of X, and X is not in beta 3. It doesn't apply. I do need the interaction term. So I come down here, and these are the ingredients that I need to figure out what the slope of X would be for any person. Given that I'm asking for the slope of x, I factor x out of both of these terms and stick it in the back. And then what's left in brackets as a linear combination are the ingredients to figuring out what the x slope would be for anybody. So now, I know that beta 2 is the effect of x when z is 0, right? What do I need to do to figure out what the effect of x is when z is 1?
So
Stick a 1 in here? Exactly. It's beta 2 plus beta 4 is the answer. So I can get my calculator out and figure out what that should be, right? But is that a good strategy? I just raised my own hand somehow. I don't have a question for myself, but thank you. Unless you count the rhetorical ones that I ask all the time. Okay, so I can get my calculator out. Oh, it's recognizing hand gestures. That's what it's doing. Okay, cool. Never mind. I learned something new today. I can get my calculator out, add beta 4 and beta 2 together, but what can't I do as easily with my calculator?
we have multiple
Standard errors, right? And if I don't have a standard error, what else don't I have?
p-value.
P-values. This, by the way, oh, I shut it. Never mind. This, by the way, is why on your homework I'm asking for estimate followed by standard error, is to keep you from getting your calculators out. Now, that being said, your calculator is a fine way to predict what your code should be doing. If you can get your calculator out and add together beta 2's estimate and beta 4's estimate, you know what it should be, then you know that the code that you write to find it is correct. So that's a fine way to check your work. But to get to the standard error, there's more complications in terms of what the formula would be, and it gets very ugly very quick. So having the software do it for you is the most rigorous approach. What if z is, if I want to know what the slope of x is for z of 5? Stick a 5 in here. So beta 2 plus beta 4 times 5 is what it would be. What if reviewer 2 comes back and is like, no, why do you care about what the slope of x is? You should care what the slope of z is. Okay, let's go the other way. I care about the slope of z now. Thanks, reviewer 2. What all do I need? Beta 3 and beta 4. Nothing else is applicable. Doesn't have z in it. Come down here. Now the ingredients after I factor z out to the back, beta 3 plus beta 4. So now the question is, for whom do you want the z-slope in terms of x? You get it automatically for x of 0. That's what beta 3 means. You don't get it for any other value unless you ask. So this is where every software package knows how to do this if you know how to ask. The ones that I'm showing you this semester, Lincom and Stata, GLHT in R. In SAS, there's something called estimate statements. In SPSS, they're called test statements. In M+, they are called model constraint and the new command. Every package has a way to do this if you know how to ask. And we will have lots more interaction terms throughout the semester, because I want you to be able to do this in any type of model, regardless of the outcome that we're predicting. Okay, 227. How are we doing? Is this feeling a little more familiar, maybe? Get the wheels turning a bit? It's been 5 days. I mean, hell, I don't remember what I did yesterday, let alone 5 days ago. So this is where then the language is. What is the pattern that you're looking at? If the signs match for the slope and the interaction slope, it's making it stronger. More positive or more negative. If the signs don't match, it's making it weaker. Other terms you may have heard, over additive interaction is an enhancement of the slope, making it stronger. Under additive is a diminishment or a reduction of the slope. All right. It's also helpful if you can put English words onto the idea of a slope. Like if you can say something like a gender gap, or the benefit of being employed, or something like that. Like the employment benefit is greater in this type of person. That's a little bit easier to process for your reader than this slope became significantly more positive by That's not a good way to go. In your homework, for instance, the idea that training is beneficial, like the training effect is what I would call the group difference between your control group and your training group. That was what the slope would be in that context. All right, let's see. We did this stuff. Let me go back to the example. We looked through an example. Let me go back to our example. Do you want to go through the model a little bit that we went over last time? Would that help? Oh, big nod. Okay. Because you were emphatic, you get your way. Big nods win. So we did this last time. This is the model that we spent Thursday on. So in this model, we have how many slopes? You don't even have to count. 6, because that's the highest number here. So note that I have an age by grip strength interaction, but I still have age and grip as the main effects. If you forget them, that is wrong. It's only an interaction if it's above and beyond the main effect slopes. That term, main effect, is only usually introduced in models that have interactions to differentiate what kind of slope you're talking about. The slope that multiplies the variable all by itself is called a main effect, as opposed to an interaction slope. So can you tell me what kind of research question would be answered by including this interaction term between age and grip strength in predicting cognition in these older adults? Say that louder, please. How much the effective age depends on grip? How the effective age on cognition depends on grip. Yes, depends on is a good way to phrase that. What if I go the other way? How the effect of grip on cognition depends on age. Depends on is one way to say it. You might also think of it as matters more or less. Does age matter more in stronger people than in weaker people? Or does age matter less in stronger people than weaker people? Here's the answer. We have an interaction. So you may often see this in results sections of people who were never taught to interpret interactions. It will be, there was a significant interaction, p less than 0.05, and that's the end of the sentence. Here's my picture. Like, no. This doesn't tell me if, let's say that I have a hypothesis that age matters less in stronger people. That's my directional hypothesis. Just knowing that this interaction term is significant doesn't tell me if I'm right about that. Because age could matter more in stronger people or age could matter less in stronger people. And without going through the process of figuring out what the pattern of the moderation is, we don't know which the answer is. So, age is bad for you. This is the slope of age minus 0.33. So for every year older you are, your predicted cognition outcome is lower by 0.33. Note that this doesn't say anything about the absolute size of an effect. Is 0.33 a lot? I don't know. What's the scale of this outcome? I think it goes up to 30. So a third of a point per year doesn't sound like a whole lot to me. But this is where effect sizes would be necessary to supplement this story. So what if I said, the older you are, the worse you do? And that's the end of my sentence. Good or not good? Incomplete. I like that. How do I complete it? The older you are, the worse you do, ... Say that again? If the grip is 9. So I would say in people with average amounts of grip strength in this sample, which is why I picked 9, the older you are, the worse you do. Yeah, conditional on grip 9. How about this one? For every pound more you can squeeze of the thingy, your cognition is predicted to be higher by 0.6. So the stronger you are, the smarter you are. Everybody head to the gym if you want better grades. Complete or incomplete? The stronger you are, the better you do on this test. Incomplete. What do I do to complete it?
Like, age.
If you're 85, the Zoomers are writing to me, yes. Because that's the point where this interaction term would drop out, and this is all you need in terms of the story. So we have the slope of grip strength in average aged people for this sample, and the slope of age in average strength people. What about these three terms right here? Do I need to add anything beyond just women do worse, dementia people do worse? Do I need to say when you're 85 or when you're strong, any of that? I do not, because in this current model, these three terms are marginal. It is true that this is the gender difference favoring men that is after controlling for your age, your grip strength, and your dementia status. But it's not conditional on any of those variables because gender does not interact with them in this model. This is the gender difference for any kind of person. Likewise, these are the dementia group differences for any kind of person. That's going to change in about 15 minutes, but not right now. Okay, with me? Any that you want to hear again or hear differently? So now the moderation question. I think that age matters less if you're strong. Am I right? This is where we got to look at the patterns. Age matters to me is like has an effect. Age is bad for you. That's what a negative slope means. So in older people, they do worse. What happens to that tendency of older people to do worse as grip strength goes up? Less worse. Yeah. So this is a less negative pattern. It's a weakening. More specifically, the way I put the numbers in the sentence, minus 0.33 is the difference in cognition per year of age when grip is 9. That age slope becomes less negative by 0.12 per pound of grip strength, per unit. So it would be minus 0.33 plus 1.2 if I have a grip of 10. It would be plus another 0.12 if grip is 11, and so forth. So if my original hypothesis is age matters less if you're strong, am I right? Yes, I am. So the deleterious effects of aging can be mitigated by a strength training program, something like that. I'm being over the top on purpose because this is not a causal inference situation. It'd be nice though. I wish that if I just worked out more, I wouldn't get old. It doesn't really work that way. Grip strength. I think that grip strength is more important in old people. That's my hypothesis. I think grip strength is going to matter more if you're old. Am I right? So grip strength matters to the tune of 0.62 per pound in 85-year-olds. That slope of 0.62 becomes more positive, stronger by 0.12 per year of age. So it's 0.62 plus 0.12 if my age is 86, plus another 0.12 if my age is 87, and so forth.
Why does it increase as the age increase?
Because now what we're talking about is the grip strength as the slope that's being moderated, and age is doing the moderation. So when you're interpreting an interaction term, it's always as the other variable increases. So if I'm talking about the slope of grip, it's as age increases. If I'm talking about the slope of age, it's as grip increases. It's always the other one. So I have two, these are called, and I'm not making this up, simple slopes. Because isn't this easy? It's so simple, duh. Whoever named that just should be, fired immediately. I want to call these complex slopes because that's what it really is. So just knowing that this is the slope of age for grip 9 and this is the slope of grip for age 85, I can tell you which way the slopes are supposed to go. But this doesn't tell me at what level of strength age stops mattering, because it's getting weaker, right? I might want to know that. Likewise, grip strength matters more in older people. Well, that means that in younger people, at some point, it doesn't matter at all. So as an additional supplement to trying to figure out what the pattern is, that's where we can get into regions of significance and simple slopes. So we went through some of the code last time to get simple slopes. The idea is to put multipliers of the fixed effects into these GLHT statements. This is our code, just to show you first with. So for instance, if I want the age slope, there's the terms in my model that have age. If I factor out age, here is the linear combination that I need to write these statements. So this line of constants right here, the first 0 is I don't need the intercept. The first one is I need one of these beta 1s, please. I don't need beta 2, I don't need beta 3, I don't need beta 4, I don't need beta 5, because they don't have age in them. Then what do I need to put for the interaction term? The number that goes here is the value of the moderator that you want the slope for. So this is for somebody with a grip of 6, because I've centered it at 9. So the first 3 rows here give me the age slope at low, medium, and high values of grip. The second 3 lines do the opposite. They give me the grip strength slope at low, medium, and high values of age. So what low, medium, and high is completely contextual on your variables. I picked -3 and +3 because 3 was roughly 1 standard deviation. I picked -5 and +5 because that was like the full range of age. There's no right or wrong answer to these. It's just designed to try and illustrate the pattern. So then here are the results. So the age slope first, if we look at the 3 estimates, the middle one is what the model gives me by default because that's where grip strength is 9, which is the simple effect of age, as they call it, the complex effect. So somewhere between grip of 9 and grip of 12, the age slope shuts off because it's significant if grip is 9. It's not significant anymore. So somewhere between grip of 9 to 12 is where age stops mattering. It crosses the threshold from significantly negative into non-significantly negative and 0. Analogously, if I want to go the other way, grip doesn't matter if you're 80, non-significant. Grip does matter if you're 85, significantly positive. Somewhere between 80 and 85 is where the grip strength slope turns on from 0 to positive. So the idea of trying to figure out where these things turn on and off as a function of the moderator is known as regions of significance. So that's what the extra piece of code here that I gave you, which I'm not asking you to do in your homework, but I wanted you to have seen in your lives. There's an R routine that will compute this for you, and I have an Excel spreadsheet that goes with the set of examples that does the same thing. So what the R output gave you is in the non-bold font here, and everything else is what I added to it to make it make sense. Because if statistical software output were understandable, I would be out of a job. So when grip is outside the interval of this to this, the slope of age is p less than 0.05. Okay. Well, let's fix this first by moving it from the centered values back to uncentered. So this is the range of the moderator at which we have a significant age slope. So basically what it means is before 9.6, it's going to be significantly negative. Between 9.6 and 18, it's non-significant. And after 18 is when it becomes significantly positive. So age becomes good for you if you just get strong enough. However, no one in our sample has a value that high. If I go the other way, if I talk about the grip strength slope as a function of age as the moderator, then grip strength is significantly negative for a slope before 70. It is non-significant between 70 and 82, and significantly positive after 82. So there's the answer. Somewhere between 80 and 85 is when this thing turns on at 82. That's what the model predicts. And last but not least, throw your reader a bone and make them a picture. So you can talk about these pictures. Usually the thing you care about is on the x-axis, and the moderator is different lines for different people. So I have it depicted both ways so that you can choose how you want to talk about it. Okay. Questions? Now that was kind of a lot, but I can make it worse. So in our previous model here, there's only one interaction term needed to evaluate how the effect of age changes by grip or vice versa, because the effects of age and the effects of grip are each described by one slope. But if age required two slopes to describe it, let's say that I had like linear age and quadratic age squared as a second predictor to make the slope of age bendy instead of straight, then I would have to multiply grip by both age and age squared. So where I'm headed, how many slopes does it take in this model to differentiate my three dementia groups? 2, they're right here. So what if I wanted to ask whether dementia had the same effect on men as it does on women? Could I do that? Sure I could. How many new interactions do I need if I want to answer that question? 2. In your homework, how many golfing groups are there? There's 4. How many slopes do you need to differentiate them? 3. So if you want to see if the effect of golfing group varies by some other thing, how many new interactions do you need? 3. Same ideas, just more terms that it takes to be able to flesh all of these things out. So I'm going to show you a 3-group example, and you get to try a 4-group example. So I'm on page 11, new stuff. So I'm going to keep my age by grip strength interaction because it contributed to the model. I'm going to add 2 more interactions that answer the question, does gender differences, do they differ by dementia status? Or alternatively, does the effect of dementia differ between men and women? My coding scheme, very important. In these types of models that involve grouping variables, summary of the results is often printed with this kind of table. So inside the table, these are called cells, and outside the table are called margins. Given my coding scheme, men are the 0, women are the 1. That means that I know I'm somewhere in this column as a reference, and then I have to know what the dementia coding is. None are the 0, and future and current are the ones in each of their variables. That means here's my reference cell. These means, by the way, are specific to someone who is age 85 and grip 9. That's known as adjusted means in ANCOVA language. Holding age and grip constant, these are the means and mean differences between my groups. So let's look at the model with respect to the table, because that's going to tell us what's going to happen. First off, beta 3. This is a slope for gender. The women are the 1. So we know that the slope is going to talk about how women differ from men. In which of my 3 dementia groups is beta 3 going to be the answer for what the slope is for gender? The question is, beta 3 is a gender difference for somebody. Given my coding scheme for dementia and the interactions of gender and dementia, what kind of person is this the gender difference for? This one, or this one?
Mom.
The none group. So dementia NF is 0 if it's none and 1 if it's future. NC is 0 if it's none and 1 if it's current. So we're talking about that one right there. Beta 3 is going to give me a coefficient of about 3, give or take. So this is the gender difference in the none group specifically. Beta 7. That's going to give me the difference of the difference, how the gender effect differs in the future group, which is the 1. So if the gender difference is about 3 here, it is still about 3. So I would expect this beta 7 coefficient to be close to 0. Men and women are not going to be more different in the future group than the current group based on these means right here. They came out of the model, by the way. What about this one? Beta 8 is going to tell me how different the gender difference is in the current group. Gender difference of 3, gender difference of like 11. So beta 8 is going to be around 8. That's one way to approach it. The other is to go down the columns. So if I start with the effect of none versus future, is this in men or women? Who's my 0 for the interacting variable? Men. Yeah, men are the 0. So that means these 2 terms would drop out, and this would be the dementia group difference in men. So it's this number versus this number. It's going to be -6. Likewise, this is the dementia group difference in men for none versus current. Now if I approach the interaction terms from the opposite perspective with gender as the moderator, I can say that in men, there's a difference of about 6. In women, there's a difference of about 6. So the interaction of beta 7 here is going to be about 0. The difference between none and future is about the same in men as it is in women. The last one, though, if I go 12 versus 13, am I doing the math right? 20. No, I'm not doing the math right. 12 versus 20. It looks like dementia has more of an impact in women than it does in men. So of the possible differences that we're interested in, I have this one as a model parameter. I have that one as a model parameter. And I have that one. I only got 3. Can you guess how I get all the other ones? You're like, no! Linear combinations. That's how. Get your calculator out. Here they are. So if I want to know what the gender difference is in any kind of person, go up to my model, find all the terms that have gender in it. There's 3. Factor gender out. What's left are the ingredients for how I get the gender slope for any kind of person. So there's 2 interaction terms involved. So beta 3 is only the gender difference when both of the interactions are 0, which is when we're talking about the none group specifically. What if I want the gender difference for the future group, in which that's what F stands for here? If I want the gender difference in the future group, I need beta 3. What do I put here? A 0 or a 1 if I want it for the future group? A 1. So I need beta 3 plus beta 7 to get what it is for the future group. Is beta 8 involved in the future group? You see an F in here anywhere? Nope, it's irrelevant. What about if I want it for the current group? I still need beta 3 as a starting point. Don't need beta 7 because there's no C in here for current. Do need beta 8. So this is why in this context of categorical predictors, interaction terms are called differences of differences. Because we're talking about difference as what the slope means, like the difference between men and women, and then whether that difference differs as a function of a moderator. I don't know about you, but that hurts my brain. So we could say something like the gender effect. Okay, let's not use the word difference. Beta 3 is the gender effect in the no dementia group. The interaction terms are going to tell us how different the gender effect is in these alternative groups. We can go the other way too. Talk about dementia group differences with men versus women as the moderator. So the difference between none and future, here are the 2 ingredients I need to differentiate it from men and women. Same thing for the difference, between current and none. And here's the missing component, which is a linear combination of those 2. On your homework, I did not ask you for all possible combinations. Fair? Didn't want it to get too ugly. So my recommendation when you're fitting your interaction model is start with the model and start with the output. Then see which extra things you don't have that you need. Don't write all possible combinations. Unless you want to. So I have, for this piece, by the way, the Stata code is at the end. I didn't put the output because it was already pretty voluminous, but I have all of the code in the output in Stata to do this exact same model, and we can go over that code if anyone is interested. Since most folks are trying to learn R, and since R is unequivocally harder, I'm going with that. So here's my model. I've got linear model as the call here, cognition is my outcome. The 1 here is to remind myself that the first term in the fixed effects is the intercept. Here's age and grip, the main effects of gender and dementia, the previous age by grip interaction, and here's my 2 new interaction terms, defined on the fly with the colon. By the way, R is not case sensitive. I put the spaces in here so I could read it better. That's all. So I have these terms separated just so they look visually easier to follow. Here's my output. So now we'll see some of the same numbers. For the sake of time, all of these numbers right here I don't need to talk about. They've changed because the model they're in has changed, but their interpretation is the same. The intercept is still cognition for an 85-year-old with 9 pounds of grip strength who's a dude without dementia. These are still the conditional effects of age and grip strength conditional on each other given the interaction term. So what has changed is the interpretation of these variables as main effects because they're part of an interaction. Okay, so if I look at this one, for instance, this is the difference between men and women. More specifically, this is how women differ from men because the coefficient is applied to the one group. So for binary predictors, the slope always tells you how the one group differs from the zero group. So it looks like men are higher, women are worse by 2.87. Is that the end of my sentence, or do I need to keep talking? Keep talking? How about you guys talk? I already have a PhD. And they can't take it back. That's the thing they don't tell you. Doesn't matter how badly your dissertation goes, they can't take it back. So women are worse by 2.87, ... When is this the only thing I need to know to talk about the effect of gender given these interaction terms? When these zero out, which is for what kind of person? What does N stand for?
No dimension.
Yeah, none. And this is why I label my variables, by the way. Highly encourage you when you're making your variables for homework and in life, label them in a way that makes sense to you. Like, don't talk about golf groups with dem and F. It's not going to go well. So yes, this is the gender difference in the none group. What happens to that gender difference in the F group, which stands for future diagnosis forthcoming? What pattern is this? More positive, less positive, more negative, less negative? Less negative. So then does the gender effect get weaker or stronger? Weaker. A less negative means they're working in opposition. Now, however, not significant, but I want you to be able to interpret the direction regardless of whether it meets the criteria for significance. So this coefficient describes how women differ from men. This coefficient describes how the future group gender difference differs. So to get to what the gender difference would be, we have to add them together. So negative 2.87 plus 0.16 is what the gender difference would be in the F group as the one. So this is an easy thing to screw up. These interaction terms do not tell you what happens in a group. They tell you how something happens differently in that group. They are always slope differences as an interaction term. So there's a negative effect of gender, meaning that women do worse. They do slightly less worse if they have future dementia. What happens if they're in the C group, the current dementia group? What happens to the gender difference now? More worse. Yeah, this is a more negative. So the gender difference is minus 2.8 in the none group. It is minus 2.8 plus minus 7.8. So all told, it's like, 11-ish or something.
So women did less, whereas in the future.
More worse.
In future.
In the future group, they do more worse. because it's a negative coefficient added a negative interaction term. Minus 3-ish plus minus 8-ish. Or this one? Okay, yes. In this one, women do less worse compared to men if they're in the future group. Is there still a gender difference in the future group? Do we know that? Does anything on this page tell me that? I know there's a gender difference in the nun group. I know that it is less of a difference in the future group. Do I know if it would still be significant in the future group? I don't know that yet. Here's why it might matter to ask that question. You would think that, well, if this number isn't really different, then it's pretty much the same, so it should still be significant in the future group, right? But that depends on how many people are in the future group. In this sample, most of the group is in the none category, like 70%. So the future group has fewer people in it. It's going to be have less power to detect gender differences within that subsample. And as I think as I recall, even though the gender difference is about the same size in the future group, it's actually not significant. Is there a gender difference in the current group? Do I know that or no? I don't know that yet. The interaction term is telling me how different the gender effect is, not what it is. I'd have to add these two together to get to what it is. What if we go the other way? Talk about dementia as the focus, gender as the moderator. The main effect of NF here, the -6, that tells me how much worse the future group does than the current group. Or the nun group, excuse me. Nun versus future. But that's in men. In women, how does the effect of nun versus future compare? Negative coefficient, positive coefficient. Less something, right? Less negative in this case. So the dementia group difference is weaker, smaller in women. This difference, though, nun versus current, in women, what is that one? Bigger, more negative. Bigger gap. So like gender gap is a way I would say, salvage that sentence, right? Or dementia gap in this case. So some of the specific comparisons are going to be model parameters. It will always be the ones for the reference group. If the question involves something about the alternative groups relative to each other, or the alternative group of one dimension, it's going to be a linear combination of some kind. Okay. 307, are we hanging in there? Sort of. I know it's a lot. The good news is that it's like those magic eye posters. Do you know what I'm talking about? Like the posters where you look at it and there's like a hidden picture inside all of the dots that appears if you stare at it long enough. I feel like these patterns are like those pictures. Like once you see like the sailboat hidden inside the dots, you can't unsee the sailboat. Or if you look at one of those optical illusions where you're not sure, like if you're looking at like, you know, the face or the lady or whatever, like once you find them, you can't unsee them. It takes a long time to get to that point sometimes, but once you like understand the algorithms that this takes, then you can do it for anything. I'm guessing that this is probably the first time you've tried to practice this with any level of detail for a lot of you. So hang in there. It does get better. Right, Vladimir?
Yeah.
Yeah, right, Mubarak? Yeah, see, I torture them in my other class too, so. But these set of concepts, though, transcend any kind of model. Linear models is a skill. All right. Let me ask a different question. How do I know if I have a significant interaction, given that I have two of them? I can't just answer with one or the other. They work together. So in the same way that the two slopes for dementia work to differentiate the three groups, the two interaction slopes work to differentiate the three groups with respect to the gender slope. So what do I need to do to answer the question, is there a significant interaction between gender and dementia? F-test, I got to put them together somehow. So this is where the next piece of output shows up. This is an example of what's known as a multivariate wall test. We're using F because we're keeping our denominator degrees of freedom for now. So this is GLHT as a separate follow-up command. So the input that it takes is the output from the previous model. So model sexdem is the name of the object that was saved out of my LM call. I try to name these things in a systematic way so that you can follow it and change it as you need to. Inside the linear contrast here, I have set each of my interaction slopes equal to 0, inside quotes. The comma between them is very important. It means don't add them together literally into one number. Set both of them equal to 0 simultaneously and keep them as two separate slopes. So then I get an F-test that is just those two and their contribution to the model. So the numerator degrees of freedom is 2 because that's the number of slopes that I've lumped into my contrast. Denominator degrees of freedom is the same as the model because this is just a subset of it. Have any of you done what's known as hierarchical regression, where you enter predictors in like layers? You haven't? You did. You just did. That's what this is. When you have a set of predictors, and then you enter another set of predictors in a block, and you look at the change in the R-square of the new set, and you get an F-test for that change in R-square, that is this. You don't have to have them in separate blocks. You just have to know how to ask for what the change would be with or versus without them. So another way of saying it is that relative to our previous model, these two new interactions are what make it different. So if my R-square went up, it has to be because of these two things. So I'm asking for a hypothesis test that goes with the change in the R-square due to these two new terms. So I can talk about this F a couple different ways. I can say, did the R-square improve significantly? P-value was 0.03, so yeah. That means the model explains more variance than it did before. And the reason that it explains more variance than it did before, more specifically, is because we've allowed moderation of the effects of dementia by gender and vice versa. So I would call this an omnibus interaction, where the word omnibus means slopes put together, all the pieces that you need to figure out the full pattern put together. Omnibus group, though, is tricky. I could put these two dementia slopes together to get an omnibus main effective group, but would only apply to the men. So I'd have to be very careful in my coding to get that answer out. That's what I'll show you next time, because it's 313. And I was right. I figured this was going to stretch into Thursday. But you should be able to finish your homework based on what we've done thus far. And if not, we'll talk about it on Thursday, and you can get the rest of the way there. Okay, any last questions before we adjourn for this garbage day? All right, thanks for hanging in there. I appreciate the fact that you're here and you're trying, Zoomers included, being here. Let me know if you need anything office hours or tomorrow. See you Thursday.